Okay, so today we're going to be doing the subarray product less than k problem. Given an array of integers nums and an integer k, return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. So for this problem, first we have 10, and that's just 1, right? Because it's less than 100. 10 times 5. Oh, okay, so actually, going back a little bit, we're going to be using this. It's sliding window or two-pointer. They're all, I mean, in this problem, it seems very similar. I don't think it really matters. I mean, I guess technically for a sliding window, like you return stuff within that said window, right? But then since two-pointer, we're just going for counting. So I think this is actually considered two-pointer. So what we're going to do here is, so we start here at 10. 10 is less than 100, right? So that's 1, because this is just one subarray. Here's 10 times 5 is 50. It's also less than 100. But here we count this as 2 because 5 is a standalone. And then the 5 times 10. So that's plus 2, right? So we're at 3. 10 times 5 times 2 does not work because that equals 100. And we want where it's strictly less than k, right? So that doesn't work. So we now move the left pointer over. 5 times 2 is 10, which is less. And that's 2. Because the 2 by the 2 standalone and then the 5 and 2. So I think we're at 5 now, right? So 5, 2, 6, that equals 60. And this is 3 because the 6 standalone, the 2, 6, and then the 5, 2, 6. So that's 3 for a total of 8, which is, well, a solution. Right. So here we have the edge case, or edge cases. We're going to do if length of nums is, oh, whoops, I forgot to close the parentheses, is equal to 0, or nums is none, or k is none. Then we want to return 0. And then this is another edge case. So if k is less than or equal to 1, then we also want to return 0. The reason why is because there's no way we can get any number less than 1, right? Like, since we're guaranteed that these are all integers, there's no way we can do anything times anything which gives us anything less than 1, right? So it has to be 0. And so now we're going to initialize variables. Let me move that up a little bit. And so here we have result is equal to 0. Stores the count of subarrays. We have left equals 0, left pointer, and so the way you code this is essentially like a sliding window for this problem specifically, but yeah. So running product is equal to 0. Okay, like I said, I need to probably wait to do my comments. Running product, just keeping track of the product we have reached so far. And this is actually 1 because 0 times anything will always be 0, right? So you have to start it at 1, which is also the reasoning for why if k is less than or equal to 1, we just return 0, because we have to start our variable at 1 and it can only keep going up from there, right? Or I mean, yeah, it can only keep going up. Yeah, even I mean, unless we have an array full of 1s, then, or like the test case, then yeah, like, I mean, I guess it's possible for us to, you know, not move, but it'll never go down in a sense, right? So now we're going to have our right pointer and move through the array. So for right in range of length of nums, we're going to do running product times equals nums right? And so this just gives us the product for whatever big our window or like the 2 pointers spans. And then so now if running, actually, I mean, that's just the condition, so there's no point in typing that comment. While running product is greater than or equal to k, then we want to do running product divided by equal to nums left, and then left plus equals 1. So this is like the example what I mentioned here, 10, 5, 2. this is equal to 100, right? So we have to shave off the number at the left for the pointer, and then make it 5 2. So like this is what we're doing here, so that we can find the window or the subarray that would allow us to fulfill the condition, right? And result plus equals right minus left plus 1. It's the same ideology as the other sliding window problems where, like let's just say, like for this, right? This is index 1, this is 0. 1 minus 0 is only 1, but it actually works for 2 because 10 and 5 is one subarray, and 5 is also another subarray, right? And the moment we move past this point, it's going to be, the answer is going to be different. It won't include like just the 5 or like just the 5, 10 anymore, right? So that's how we do that. And we just return result. And that should be it. Yep, there we go.